Welcome to Game Creator 2014, our third workshop. Today we're going to have Högni talk about game engines for us. Before we go there, I got asked a very simple and silly question last time. Who am I? And I kind of realized I haven't really introduced myself. I'm Jói. I'm Jóhannes Sigurðsson. I'm the organizer of Game Creator and member of the Icelandic game industry. So if there are any questions regarding the competition, you can direct them at me. You can send me an email at johannes.sigurdsson@igi.is. So keep that in mind at least. Like I said, we're going to have Högni talk about game engines today. And again, this video will be available on gamecreator.igi.is. So you can watch it there if you need to review it. Without further ado, let's have Högni.
All right, thanks. Hi, everyone. I'm Högni Vilhjálmsson. I am an associate professor of computer science here at Reykjavík University. I teach a number of courses here. I teach a course on virtual environments. I've been teaching some courses on artificial intelligence. And I also have a course called Game Engine Architecture. And that is a requirement course for everyone who is taking the game development emphasis line in computer science. So I have, saying a little bit about my background, maybe I'm not, you could say, strictly from the game industry, although I have actually co-founded 2 game companies. I've not really worked as a game programmer for any amount of time, but I've used game engines in my work, and I've used game engines, for example, for some research work that I've been doing. And currently, here at the Reykjavík University, we are using a couple of game engines for sort of game-related artificial intelligence technologies that I will not cover in this talk, but at the very least, I feel like game engines are kind of popping up everywhere in my work, no matter what I do. And I'll come back to that later, how flexible and interesting these things are as technologies. So I'm going to start really with a bit of a historic overview. So today, maybe I can sort of give you the impression of the extent of like this, the history of these things. And kind of how they're always becoming more and more capable as people are adding more features and increasing the sort of how they can simulate reality. Because in some ways, game engines are sort of like simulators. They simulate a world that we describe to them, and they give us back that world to interact with. And that is one way to think about it. It's a truly dynamic real-time simulation engines. I admit that my focus is pretty much mostly on the 3D engines. I will show you one engine that is a 2D engine, but I hope that you can still kind of extend this to include other engines as well. So to start with, I just wanted to introduce the concept of a game engine. One thing that really distinguishes a game engine from other kinds of software, or something that is a primary concern of a game engine, is that it is designed specifically to be data-driven. And when you design an application to be data-driven, you are really saying that you are separating the mechanics of computation and processing from the actual data that it's using in its processing. So you are trying to make sure that you have some kind of a set of functions and algorithms that do its work properly, but then you just want to shovel data into it and let it crunch on the data. And if these functions and algorithms are correctly implemented, on the other end, you get your output in the form that you really wish to get it in. And in the game engine example, we want to get games as the output. So we want to insert the data for the simulator to simulate the data with, and then we want to get in the output some interactive simulation that we can interact with. This is a very important thing. This is a very important concept that you are doing this abstraction, because if we are talking about game engines being able to almost simulate reality of some sort, or kind of create a world, the type of world and the kinds of things in the world are simply being shoveled into one end of it. And then we get the world we want on the outside. And this means that we can take the same engine and build many worlds. We can just change the data that goes in, and we get a different kind of a game environment on the other side. So this is a very simplified picture, but it is a core concept here that we can reuse our computation here in the middle and apply it to many different game worlds. A slightly more elaborated picture is this one. It's the same picture, we're just looking inside a little bit more. And here we treat the game engine as the cogs and wheels here at the bottom that do all the processing and crunching and displaying of our environments. And then on top we have the data that has now been inserted into this engine. And this data is is of a very simple type in a way. It is really just a scene with what we call game objects in it. And so there's a part of the data that we are shoveling in from this side, part of the data that we are giving the engine is a description of a scene of some sort. And this is the room, this is the world, this is the island, this is the environment that we want to be in, and we do it in a certain way. So we describe that scene to the engine, and then we build assets. And we build assets that there's 3D models and textures and all kinds of audio and these kinds of things. And we use digital content creation tools. It's usually often abbreviated DCC. So using these tools like Photoshop, 3D Studio, Maya, and these kinds of things, we build these objects that are visible or audible inside the scene, and we can insert them up there at the top. So this is part of what we're shoveling into the engine. There's one more thing that is missing. I mean, if we did this, we would end up with some kind of like a nice painting of an environment. Here are our mountains, and here are our valleys and trees, and there are some things sitting out in this nice environment, but nothing is happening. At this point, we have not started the simulation as such. A simulation is really some kind of a software that creates a dynamic relationship between objects, and objects can affect the behavior of other objects around them in some sense. And in order for objects to interact, we need behavior. So any of these game objects that already have a visual appearance, for example, through the assets, they can also get some behavior that we want to ascribe to them. And we describe these behaviors usually using some kind of a scripting language, a programming language that is often interpreted or at a high level. And this programming language describes exactly how that game object would respond to another game object in that environment. But notice that this is all happening above the game engine. So these are facilities that the game engine should provide. The facility to import or describe scenes, to import assets, and to script behaviors for the game objects. And typically that's all you need. To make a game, that's all you are working with at the top. If you are lucky enough to have access to a game engine that will do the rest for you, which is to run the simulation and give you the visual output at the end. But certainly, in some cases, you might have to go under the surface, and you might want to edit the actual simulation mechanism under the hood. And in those cases, you will need the source code access into the game engine itself. And it's a very important distinction to make, that when you're thinking about, okay, I'm going to program a game, One way to program the game is all through those upper layers there. And for example, the behavior, the game mechanics and all of those things are all scripted in a scripting language. And that's above the engine. But that's different from saying, okay, now I'm going to start writing the actual game engine code. And it's typically a different language from the scripting language. A game engine might be available as a C++ open source library, and that's your game engine down here. And you can go and recompile the game engine, you can look at the code, you can work with it. But that same game engine might provide a scripting interface for behavior, and that could be, I don't know, Python even. I was working with a game engine that was exactly that. It was written in C++, big libraries, and we could compile the whole thing, but then all of our environments were written in Python. Something to keep in mind. We'll come back to that point later. So now I'm going to give a little bit of the historical perspective, and maybe this is a familiar picture, the Wolfenstein 3D first-person shooter. It's kind of celebrated as the first, successful first-person shooter. There were other games that were using kind of a 3D environments that were not shooters, like Ultima Underworld at this time. But id Technologies, id Software, they developed an incredibly fast way of rendering 3D environments, and they could, with a great ease, populate big environments with a lot of 3D characters that, although they were just drawn as sprites, and it's kind of not real 3D in a sense, this really captured people's imagination. The fact that you could run around these 3D environments and shoot bad people seemed to just captivate a lot of people, and this game went everywhere. Soon after this game was out, there were groups of people thinking, well, okay, this is a really cool engine. I mean, we should be able to change these things. We should be able to change the way things look in this if we can locate these little images that are stored for Wolfenstein, and we can put on our own images, and we could make any world we want. So people started taking this thing apart and replacing textures, doing things like this, like Santa World or something like that. Crazy things. I mean, there were, you could probably find old Wolfenstein mods that kind of imitate all kinds of cartoons and so on. This was not intended in the beginning. I mean, when Wolfenstein came out, id Software was only concerned about, okay, you're going to make a really cool technology here with a first-person shooter type of game, but they didn't really think that the community would start doing this type of thing. But they understood the implications, they understood the power that they were giving people. They would give them such a 3D engine. So their next project, which was Doom, they actually explicitly thought, okay, we're going to make this moddable or modifiable by the public. So we're going to separate their data, like we saw in the picture earlier. Their data is going to be very well put aside from the engine itself, and people should be able to open up the data files and mess with the data files, change the input to the engine to get different outputs. So that was the original Doom engine that came out not long after, actually, Wolfenstein 3D. The Doom engine came out just a year later, really. But they immediately started working on it. And the incredibly nice thing about this was that this data separation, and the data was all stored in a file called WAD, which stood for Where is all my data? And that's file, if you get a hold of it, you can edit it, and you can make your own WAD files. And even today, you can find on the internet, like you can find, in fact, all of the id Software Technologies game engines up to the last one are now free and open source on the web, even back to the old Doom engine. So you can actually legally acquire this original Doom engine, and you can legally then acquire some of the mods that are out there from the original Doom, and you can see what people are really doing with it. We'll come back to it a little bit later, how people are modding these things. So this established id Software as one of the main players in this field of game engines, because it was literally releasing a game and at the same time knowingly releasing a game engine for other peoples to use and mod. And so id Software has continued this process of updating their engines throughout the years. And as you probably know, John Carmack, who was like the lead software guy at the time and no longer there though, he was always interested in showing off like the latest technology, like how he was always pushing the boundary of what was possible in 3D gaming, in 3D simulation. And so with every iteration, there was a certain push towards some kind of perfection here. So in Quake, in the Quake engine that came out after Doom, this engine went full 3D. So you actually have a fully realized 3D environment. So they're no longer sprites, they're actually articulated figures. All the characters in there have skeletons and they move around almost, you know, like humanoids should do. And they were doing things with lighting, and they were doing things that were quite amazing at the time. They included both a software renderer, but they also included support for graphics hardware. So at this time in 96, you were just getting kind of these 3D cards that you could stick into your machines, and they would accelerate your graphics if the graphics were in fact talking to them. And there were not many talking to those boards at the beginning, but of course id Software wanted to stay ahead, and they truly supported the first graphic processing units. And this engine here was also introduced a scripting language, which they called Quake C. And it's kind of a variant of the C language in which this game is actually written. It's written in C, not C++, but C. And the scripting language allowed you to then attach behaviors and recreate how these different elements and game objects interact with each other. So there again, they are thinking, okay, we have an engine, and then you can change the data as you want, and you can also change the behavior of all the elements in this environment. This introduction of the Quake engine there, which is after the fact labeled id Tech 2, this was the foundation for many other game engines that we are seeing today, and we'll come back to that in a minute. But id Software didn't stop there. They kept going. Quake 3 Arena was another upgrade in the id Tech 3, if you want to call it that. Again, pushing certain things, and although the first the Quake engine it did actually support networked multiplayer. It didn't actually. I mean, at the time when Quake 1 came out, people were just doing LAN parties. I mean, they were playing multiplayer games on local area networks, but there was a push for getting things out of the internet. And getting things out of the internet and using the internet protocols was something that was very difficult to accomplish. There was a lot of lag to work with. And in that id Tech 2, they had kind of an upgrade where I think it was called Quake World or something like that. They basically did something where they addressed the problems of internet play. And that in itself was a great technical achievement, and this is something they perfected really in Quake 3 Arena, was the internet play. And this is something that, again, was a foundation for many different other games that wanted to achieve a very smooth, fast internet play in first-person shooters. They're still using C as their language here, and then something happened when they went to id Tech 4, where they actually decided to go into C++ as the main development language for the game itself. So they actually kind of re-implemented many things between id Tech 3 and 4. They kind of rethought the whole thing, and there's a whole new package coming out. And in id Tech 4 and the Doom 3 was the showcase, almost the tech demo for this version of the engine. They were really pushing the realism of the rendering here. And they were doing things with light and shadow that really hadn't been done before. At this point in time, they're also going into what is called programmable shaders. They're really uploading shader programs onto the GPU to make the maximum use of the graphical processing unit. And so they were able to do things in kind of a massively parallel way. And one of the things that they're doing here that was never done before, I think they were probably one of the first game engines to do, was to do what is called a per pixel lighting. They're calculating the lighting of every single pixel on the screen rather than focusing just on whole polygons or vertices in the models and kind of trick you into thinking that they're actually doing full shading. But here they're really doing a very detailed lighting model. And this really shows, if you just kind of compare these two pictures, how you get this incredible photorealism almost in their graphics. This technology, ITTEC 4, you could say Doom 4 was maybe, and Doom 3 was kind of the showcase for it. What they really wanted was to have other companies come in and use this technology, and that's what happened, of course. It was a fairly popular engine, but the game not so popular. After this, they kept pushing it, of course, and the latest iteration was ITTEC 5, and that was the showcase there was the Rage, a game called Rage that came from them as well. And here they were again pushing the envelope even further, and it's also C++, everything written in C++. And here they were talking about things like texture detail, that they wanted to introduce what we called mega textures. Incredible detail, photorealistic detail on all surfaces. And the way that they handle these mega textures is completely new technology at this point, how they can ship this huge data around and work with this huge data on the GPU as well as the CPU. So this has been the progression in game engine technology from id Software. And I put it up there kind of as the main timeline because they've kind of been in the business for the longest, you could say, creating game engines like that for 3D games. And they're still in the business and they're still pushing the envelope. And we'll see what John Carmack does now when he's now joined Oculus Rift to do other things. But I think the id Software will still continue. To then take that timeline and just put it a little bit aside, we have another important development happening at Valve. And Valve wanted to create stories as well as first-person shooting experiences, but they were really wanted to embed that shooting experience in a rich story environment. And they decided to use the Quake engine, in fact. So they took the Quake engine, ITTEC 2, actually Quake engine, and they modified it heavily. They got the license for the source code. They used some of the original source code, but they also added things on top. One of the things they immediately started doing was to take things out, to write things in C++. For those that are, you may not all be familiar with the difference between C and C++, but C is not object-oriented, and C++ is an object-oriented language. And so there's a different approach kind of to thinking about your software in some sense. And object-oriented approaches make a lot of sense when you're talking about game objects. Valve was using C++, their own version of the Quake engine here to build Half-Life. And then they developed from there their next version of their engine, basically, that they call the source engine. And by this point, there's still few lines of code still there from the original Quake code, but at this point, most of the things are now in C++, and it's basically their own proprietary software. And one of the things that they did, that they were looking into also realism of their simulations. And I remember like the first demos that came from the source engine, they included what was called the dynamic range rendering. So that they were kind of faking this effect of having bright lights outside and dim environments inside, being able to to experience the full scale. So when you go from a bright environment into a dark environment, everything is dark first, and then slowly you see better as your eyes adjust to the darkness. And things like that were all incorporated into their engine. They were also working on refraction, which is like the water surfaces, that you can actually see through the water surfaces objects at the bottom and see how they refract in the water. So there were all kinds of nice things that they were introducing to the graphical rendering of environments. One of the things that was not so great, well, they've sort of been criticized a little bit. Valve has been criticized a bit for not giving out very good support tools for using their engine, for modding their engine and doing things with the engine. They have a kind of an archaic scripting language. I don't remember what it's called, Squirrel or something. There's some kind of scripting, but the scripting is only for certain types of objects and other things not. And it is not a very kind of a unified, nice environment to work in if you want to create a Half-Life based game. And even their editor technology is kind of outdated and old. So that was maybe holding back some of the developments from the source engine, but there was another contender here, and that was Epic. And Epic Games, they came out with a game called Unreal around the same time that Half-Life came out. And Epic, they actually took a different stance to the whole thing. They immediately were thinking about the modding of games. They were immediately thinking about, they were kind of thinking a little bit like id Software, that they want to bring really powerful tools into the hands of game developers and also amateurs that wanted to play with these things. They were probably one of the first ones to start writing in C++. So they built their own engine. They were not deriving directly from any of the Quake ones, but they built their own engine in C++. And they also created another language, a scripting language on top of their engine called Unreal Script. It's kind of like a C++-like language, so it's not hard to pick up, really. But remember the image that I had in the first slide there, or one of the first slides where I had the game engine on the bottom and then all the stuff on top, and there's a scripting language on top. So the game engine is all C++ and the scripting is in Unreal Script, and Unreal Script was a very powerful script. You could take any of the game objects that the Unreal developers had created for their games, and then you could derive from those objects new objects and change the way that they behave very easily. Especially when Unreal Engine 2 came out, they had really perfected this. The editor, the scripting language, the environment to update their games. And they were really getting this engine into the hands of a lot of different developers. One of them was the America's Army, was basically the government in the US. They picked up the Unreal Engine to use as a propaganda tool for the military. They developed this game called America's Army, which is a network. And that was another thing that Unreal did really well, especially in the second version, was the networking. Their competitor was really Quake 3 there at that point. And they kind of, in the beginning, they were behind Quake 3 Arena, but then they got really kind of, I would say, ahead, because they did some really nice things with multiplayer Unreal Tournament game, if you're familiar with that one. And America's Army was built on the same as the Unreal Tournament game. So this is something that is, but this is only one example of this. America's Army was actually the showcase of this engine. The tournament game came a bit later. In fact, there was Unreal Tournament 2003 came a year later to showcase the technology. And so in some ways, Epic has been relying on other game developers to showcase their technology. You can kind of see a little bit also how they're thinking. They're really thinking of this as a fundamental technology for others to use. And even when Unreal Engine 3 came out, really the showcase was Gears of War. So all of these things are kind of matching up a little bit to the id timeline at the top. You can see by the time you get here, then you're getting programmable shaders and much richer textures, much bigger textures, and so on. But they're also updating their editing environments. And one of the things that they're also doing more and more of is to support the artificial intelligence editing. So they have some visual tools at this point to visually edit the AI of all of the characters in the game. So these are, in my mind at least, these were the main three players in the 3D game engine sphere, kind of the strongest players, the id Software and Valve and Epic. And from all of these three, you can see so many different projects come out of them. And one of the, and I was not kidding when Epic really was thinking about getting these things into the hands of players, because if you bought one of these games, if you bought Unreal Tournament, you also got the editor with it. And they still do it. They just ship the whole thing with you. So you buy the game, but you're also buying all the same tools that they use to make the game. And this was a very conscious effort to get this thing into the hands of everyone. There are other engines, of course, then that come also a little bit later into the game. Maybe most notably, the CryEngine has from Crytek, and they've developed games like Far Cry and Crysis, and they built their own engine, and this was one of the most amazing engines to come out at the time. One of the things that they did particularly well was outdoor environments, because their first game was all about an outdoor environment, a very rich and very large outdoor environment, and they still continue to lead that game pretty much. The detail that they can get out of outdoor environments. You have tools like Unity that was not developed for any particular game, but was always thought of as, here is a generic tool to make games. And then, people can just run with it. So we'll come back to the Unity engine maybe in a minute, but that is also a strong player that is always getting stronger. There is Gamebryo. Gamebryo is more like a set of libraries that deal with things like animation, and rendering and materials and all of these things. Sound. The Gamebryo is a set of development libraries for pretty serious developers. It's not the kind of not a nice package to pick up by everyone, and it's also very expensive to incorporate into your games and license. But some very major game companies have licensed these libraries. Including Bethesda with Skyrim. So Skyrim is actually using the Gamebryo game engine libraries to render its environment. So obviously they're doing some really, really good things there. And Frostbite is from DICE. Those are the people that were doing Battlefield games and Mirror's Edge and so on. So they've also been doing very well in the outdoor environment, and this latest one is focusing here on very dynamic, rich, natural environments, as you can see. And I just realized almost after the fact, when I put these pictures together, that they're all focusing on nature. I mean, this is kind of like you can get sort of like, okay, shooting everyone, blood everywhere, post-apocalyptic worlds, and then a bright future, everything green, peaceful. Even like the scary guy from Crysis there is kind of like really peacefully walking through the woods. But yeah, they're trying to get closer and closer to nature. You could say that's kind of that's kind of like what they compare themselves to. You could say it's the engine that they have and the nature outside the window. So now I'm gonna talk a little bit about your ways of changing things. So what do you do when you want to make your own game? There are different paths you can take. And one path is to take an existing game and modify it to a lesser or greater degree. But kind of lesser modifications, they tend to just not change the fundamental gameplay of the original game, or not necessarily shift even the world that you're in. So you will see things like, okay, you have people adding some visual detail to the world of Skyrim. And for example, this mod or modification adds the Milky Way into the sky. So now if you look up, you see the Milky Way represented. And that's a nice touch to the environment. And that, and you will see it, of course, if you're playing this game, you've seen how many different mods there are to change the experience, to improve the experience in some dimension. This can be purely visual, but sometimes they actually also give you some quests, some additional things to do. So you could, if you wanted to test out your idea for, say, a murder mystery or something, you could in fact just sort of mod an existing world, like a Skyrim world, and add that murder mystery to that world, so that you would stumble across that corpse or something and then start investigation. So you can script the interactions with the characters as well as a part of modding this particular game. But it's all set in that game world. And then we have things like, here is the Portal game, and again, this is actually a mod that is supposed to take place before the events of Portal, and it links it kind of into the Half-Life universe. So it gives you the impression, well, actually this is a part of the Half-Life universe, which might make sense since this is from Valve, the same developer, Half-Life and Portal. So you have sort of crossovers happening there, but it's kind of in a subtle way. So we are still talking about simple modifications of existing games and game mechanics. The next step up from that, so you can accomplish this, sometimes you can accomplish this purely through just changing some assets, like changing and replacing a texture. Sometimes you need to go a little bit further, do a little bit of scripting as well, but there's nothing necessarily major about this. But then we have something called the total conversion modification. And those tend to be kind of like almost purist in the approach. They strip all the data out of the engine typically, or often. They strip all the data out and bring in their own assets from scratch, like make everything from scratch. And including like the main menus and all the user interfaces and things like that. So when you launch that old game, you no longer recognize it, more or less. One of my favorite ones, although it does use some of the old assets here, was a Star Wars modification, total conversion of the Doom game that really took place, like the events of the Star Wars movie, which I think now is number 4, were just recreated in the original Doom engine. And they had all the characters in there and the weapons, everything, and the layouts of the environments. You really actually could identify that you were inside the Death Star. You could really identify the different locations, even if the graphics were rather poor. And that's an example of a total conversion. Another total conversion of Doom was the Aliens. Take the Aliens theme of the Aliens movies. That was an incredibly successful one as well. This one over here is actually one that I was doing as a part of a research project and a grant in the US, where we were tasked with creating a language and culture training environment using a game engine, and basically build a game where you would have to use and learn a foreign language. And in our case, we had to teach Arabic, which is a very difficult language to accomplish. So we created very good, nice learning materials for Arabic. And then to try out your skills in Arabic, you have to walk around the streets of an Iraqi city and have conversations with the characters, the people that you meet. So in fact, with your mouse, you click, and when you click the mouse, you speak into the microphone. And you speak in Arabic, and when you're done speaking, then the character will speak back to you in Arabic, and that's the way you have conversations. And you have certain tasks to accomplish as a member of the special operations in the US military. And you have to establish some kind of a contact in the city and so on. So it's kind of like an adventure game with a certain goal. and you accomplish these goals all through talking and all through social interaction. You may actually also have to be aware of your non-verbal behavior. So you have to place your hand on your heart to show sincerity in certain cases. So you are manipulating the way that you are representing your avatar in this environment. So it's a completely peaceful interaction. In fact, if things escalate to the point of where you would expect some violence or there would be any shooting, that would be the end of the game. That would be you would lose if it came to that point. So clearly, the fact that we were using the Unreal Tournament game engine and we were modding it, we were not actually going into any of the source code or anything. We were just changing the assets, just changing the script. We were only using the Unreal script to do the behaviors, and we were also able to use, because it's a network game, we also used a kind of a trick here. The characters that you interact with, they're actually networked players. And then on the back end, we have a server that speaks through these characters, and that server in the background was just a Python program. So we actually had, you could say, a mixture of things going on. We had a certain part of the logic all in Unreal script, and a certain part of the logic was coming from the internet, through an internet connection, kind of a way around some of the limitations of Unreal script in that case. So there was all these possibilities here, and you kind of stop recognizing the original game, especially if you think you can grab your gun, because there is no gun to grab. But I have to tell you, though, that when we put the first versions, prototypes of this, into the hands of students who were playing around with this, they actually, it only took them about 5 minutes to kill everyone in these scenes. Anyone have an idea how they did that? You don't have any guns. No, they did not have to do that at all. But that's right, they could have done that maybe. No, they managed to get up on top of the tables and then on top of the roof and then jump from the roof and on top of their heads. And that was just an insta-kill somehow. And they were able to kill everyone by jumping on their heads. And that was just because some of the original classes that described those game objects, the characters, they were still there. We were just deriving from them, and we were changing certain things. But there were certain things that the parent classes there already had built in, and we clearly had to go back and take some of those out. So people seem to find ways to exploit these kind of things and find ways to kill each other, which is kind of sad in some ways. But also kind of funny in the context of what we were trying to do here. Okay, so that's something that you could do. And again, we did this by, you know what our investment was in terms of game engine? It was $15 to do this. I mean, in terms of the game engine itself, because we went out to the store and we bought Unreal Tournament 2003, and that was $15, and then bought it back and then modded it to this effect. But of course, we had a lot of manpower also to do with the graphics and so on. Some classic mods. So starting like that often turns into a game that then gets its own engine, or basically it gets full release as its own game at a later point. And some of these you might recognize that all started as modifications of existing games. The Defense of the Ancients was a modification to Warcraft 3, which is now Dota, and now Dota 2 is like a completely different game, you could say. Team Fortress was a Quake mod, Call of Duty was a Quake 3 mod. Dear Esther and Stanley Parable are kind of these very fascinating story environments, and they were both built as Half-Life mods at some point. So you can all start with modding. There's nothing. It's not sort of like the end point. It's often the starting point of some of the larger projects. Some of the total conversion mods are absolutely stunning, and you really do not recognize the original game engine. And here is a Half-Life 2 mod that took the Half-Life source engine and created a 2D platformer out of it. And it is a fascinating platformer because you are playing the platformer here is one screen. If you were playing the platformer, you hit the key and the entire scene flips over, and that's the same scene from the other side. So each scene has a dark side and a happy, colorful side. And your protagonist also has certain behaviors that only get accessed in one of these sides. So it is kind of it's a really astonishing game. It's artistically a kind of a fun game with all this originally drawn art. But this just goes to show that even the craziest ideas for games can be implemented simply by taking an engine and then modifying it to an extreme. And you can get something like this. And this was one of the finalists in the Independent Game Foundation competition in 2008, I think. So it was quite successful as a mod. And then we have, well, I'm kind of skipping here maybe the one step where you would actually license the engine and get the source code for the engine, but most people don't go that way to begin with. Instead of saying licensing the Unreal Engine or licensing from these bigger engines, which cost a lot of money, but you get the full source and you can edit the source and try to make your first game from the ground up like that. But that is both incredibly expensive because these engines go for hundreds of thousands of dollars, just the license to get the full source and use it. And also there's an incredible, of course, learning curve to get into the engine. We actually, for this game, we did that actually. We did go at some point and got and licensed the Unreal Engine 2.5 from Epic. And we did move that ultimately into a full game based on the source code. But if you're interested in that discussion, I can have that also offline. You know why you want to make that move, but you have more flexibility, but it's a lot more work. The other way to go, if you really want to make a kind of a game not tied into a sort of a game that already exists, is to use tools, flexible general tools that allow full freedom kind of to do your own game from scratch. And so you're not building on top of a game, you start with a new project with nothing in it, and then you start from there to build your own games. And Unity is such a game engine that it's kind of like your blank slate. Go ahead and do with it what you want. And that's kind of in the 3D games and also now platformer game realm. They have support for those types of games as well. And then we have adventure games. They have for a long time been using an engine called Adventure Game Studio to create these adventure games from scratch as well, with your own original art. So these are all your different paths to take. Well, okay, yeah, these were the source license games. Right? I had the picture from that, in fact. I wanted to mention two games that licensed an engine and then made a pretty fantastically looking and fun games. And one was the America's McGee's Alice, who took the Quake engine and did some incredible level design for that game at the time, and did some incredible visuals for it. And it's just a piece of art, really, that came out of using the Quake engine. And this is, I think, the most beautiful Quake game out there, I think. I mean, I keep coming back to it. It's just astonishing. And then we have Deus Ex, who they licensed the Unreal Engine, and they, as you may know, the Deus Ex was a very successful game in sort of like the sandbox approach of solving problems and the level of story that was involved. So they did a fantastic job also of going way beyond the original Unreal Engine. But again, these two had access to the source. So these were not considered mods, but really standalone games. So I'm now done with my slides, and I wanted to maybe, and I'm not going to spend too much time, more time, but I wanted to show you maybe sort of inside a couple of these game engines. Just switch to the laptop here. Okay. So let's hope we get something up here. Okay. So one thing I wanted to show you was if you happen to own any of the Epic games from Epic, like the Unreal Tournament games, one thing that you might want to do just to kind of test it out is to look in your, these are games here on Steam. I don't know if you're using Steam, but you can buy these games there. And let's see here. I have Unreal Tournament 3 here as one of the games. And if you go into tools in Steam and you scroll through the different tools, most of them are actually dedicated servers for different multiplayer games, but some of them are development kits. And in this case, there is an Unreal development kit right there. And you can simply just install it. And what happens when you install it, and this, of course, is only possible if you have purchased the game, but these games are pretty cheap now. They're old games. And once you have done that, then when you right-click on it in Steam, you can say here, launch editor, right there, Unreal editor. And what happens next, I mean, it's pretty, let's see if, okay, I shouldn't say anything until it actually happens, because that's kind of shooting myself in the foot, I guess. It starts up the editor, okay. And this is the same tool that the developers used to create the actual game. What is kind of nice when it's attached to an existing game like Unreal Tournament 3 is that you also get all the assets along with it. I mean, you own the assets because you bought the game, so that's now in your library of things that you can use. And of course, that's easy then to modify an existing level or something like that. But this is the Unreal editor, and one thing that distinguishes maybe the Unreal editor and the Unreal Engine from some of the other ones is that it's kind of rooted in the old style of games that were all indoors, where you were kind of inside different tunnels or facilities or something like that. And so by default, I think what you need to do to build a world is to carve out the space, like you are kind of digging, like Minecraft, I suppose. Like you start digging inside to make rooms and levels and things like that. So the concept here is that you have a brush, and it's a 3D brush, and 3D brush meaning that it's basically a cube, or you can change the shape of it. And you situate the cube in 3D space, and then you carve out that space by pressing a button, and it removes the material from that spot and leaves a hole. And we can hope that maybe that works. This is my brush here in one of the views, and here's a 3D view down here, and I think. And now if I press subtract, then here are the walls. Here we go. Okay. So this is actually the room that I just created. I cut it out from the blackness, the void, the black void. Now there's a room in it. And inside the room, I can place things. And it's really all of the game engines, all of the game editors and game engines, they have the same exact main structure, which is that, okay, you have a scene, you set up a scene, and then it's populated with game objects. And a game object is that dynamic entity that the simulator is simulating throughout the lifetime of the game. And each game object is associated with some data, like the appearance, and some behavior. And that's how it interacts with other game objects. And so it's always about, okay, you build the environment, and then you throw in game objects into the simulation. And then you start the simulation and see what happens. So the first two things that you want to throw into this environment, for example, would be let's say a light. So this is a light source that I'm now placing inside the world here. Okay. So that's to enable us to see the environment. And again, this is actually a game object. This little light is a game object. And with any simulation, that game object will interact with other objects in the environment. So it will, in fact, change the way that these walls are going to be rendered in the end. But the light itself won't be visible in the game, but it's represented as a game object in 3D space nevertheless, because it has a property that is its location. And another thing that I definitely want to add is the player start. So here is another game object that maintains the spawning point of the player. So now I have two game objects in here and an environment. And that might be enough actually to just start the game. I have to build the lighting. It does some pre-processing of lighting before you can run the map. And this is good. And then I can start. Whoops. Where is it? Here I am. And now I'm inside the world that I just created. So there's a lit room here. And I'm walking around the bottom. And this is your first step. And now, I mean, the rest is up to you. I mean, you go and pick objects and you insert them in there. You carve out more space. It's very easy to carve out more space, making different brushes. And you get this all on top of the Unreal Engine. And Unreal Script allows you to take objects that you're using. So you could take, for example, a player start and create a new class of a player start and then add something to it. And that's your player start now. And all you have to do is to then just browse to it in the browser of objects. And you now have your new object in there and you can insert it. So this is an editor that does everything pretty much. The only other tool that you would need, apart from just drawing tools and things like that, is a script editor. So Unreal Script is of course a programming language, and there are some Unreal Script editors out there that are specifically for Unreal Script, or if you're using Notepad++, you can have Unreal Script as one of the supported languages in that. So it's quite easy and nice to edit Unreal Script, in fact. So that's Unreal, and this is something that you can start playing with if you like. But I think in general, you would want to consider that if you're talking about, okay, I want to do something indoors, lot of, like a maze or something like that. This is a perfect tool for building a maze. The other tool, other game engine that I have also mentioned a little bit is the CryEngine. So we can start that one up here really quick too. And this is kind of the flip side in some ways to the Unreal Engine, that here the goal at the beginning was outdoor environments. So really they wanted to start from the fundamental assumption that you were creating a terrain. And so if you do a new level in the CryEngine like that, okay, something like that, you already have to specify some resolution for your mesh that represents the terrain of this environment. It's very different from what you would see from the Unreal Engine, for example. And when you do that, so okay, now you're into, well, it's doing some crunching here, and I'll just go through the default setting. But look at that. I mean, this is completely different from the Unreal Engine. The starting point is an ocean with nothing, with a blue sky, and you can even go down to the ocean level. You can see this is just a real ocean. So that's kind of so now we have to think in terms of, okay, how do I want to fill this now? And most logically, you won't be thinking, well, I need an island. So you will go into the terrain menu and say, okay, I want to edit the terrain. And terrain in this is just it's a height map that you create. It's a texture where the level of whiteness of the texture is the height in that position. So if this is a map of the environment, white would be the peaks, and I can actually ask the CryEngine to generate a texture for me, so I don't have to start from scratch. So I generate a texture. This is basically a small interface that controls the mathematical functions that distort the black and white image. And I can make it just use the defaults. I'll use all the defaults here so that it generated this. So the mathematical functions went in and it generated basically a noise from a noise. It's called kind of a continuous noise. So there are no truly sharp edges. It's all kind of smoothly going up or down, up and down, up and down. And the black areas are the lowest areas, and the white areas are the highest areas. And if it doesn't look like an island, well, it's kind of a square. I think no island would look just like that. It has a little bit of tools to modify the result of this generation. So you can say, make an island out of it. And I think it kind of crops it a little bit more to make it look a little bit more like an island. So that was just a couple of clicks. So where is my island actually? We have to move around to be able to see it. I'm inside it, and that's why I couldn't see it. It was generated right on top of me. So this is our island now. It's kind of a strange mountainous place. And if I'm not happy with it, of course, there's a terrain modification tool where I can simply can just edit it, raising and lower certain paths, and I can lower these tops there that are way too high. So now I just have these paint tools basically, and I can push things down with the paint tool, I can pull them up with the paint tool, and I can do very detailed editing. And so I can make little kind of alcoves like that, little fjords or whatever. And I'm doing this all visual at this point. And you can go pretty far with this tool, creating very, very fantastic environments. And I won't have time here to go into the details of it, but the next thing that you would want to do is to paint it in different colors according to maybe the heights of things like that. And there are some very powerful painting tools in here that literally paint the texture on top of this. And then can introduce variations in texture, close-up texture and also far away colors and textures. And so you can really zoom in quite close and get a lot of detail. And you can also spread out some trees. And I think within maybe an hour of playing with these things and with a tutorial or two, you will be creating incredible outdoor environments in no time. And at any point in time, you can switch to the game. Well, the game being basically the Crysis game. I died because I materialized a little too high up. So if I can get myself back on the terrain, sort of be here a little bit closer maybe, hopefully I won't die, and I can switch to the game here. So okay, so here now I'm standing here with the default type of Crysis type of weapon and GUI, but this can all be changed. So now again, this is a little bit different from the Unreal Engine, but you can see that in some ways we are doing the same things. We're creating an environment, and then I can start adding objects to this environment, and I just insert game objects. And obviously my character and the spawning point are a couple of objects. To see the amount of objects that get created in one game, you can look at the demo that they have provided with this engine. This is the forest level. This is basically kind of a tutorial level, or just a level to show what the engine can do. This is a fully populated map in the CryEngine, and you can see, okay, there is a lot of geometry. There's a lot of trees. There's rocks. There are many details happening here, but a lot of the things in the environment are not visible game objects. There are sound objects. There are effect objects. There are light objects. They're all visible in the editor, and you can go into any of them and change their parameters. And again, we're taking game objects as a combination of data and action or behavior. So any of these things potentially have both. And you can script these behaviors, and you can edit the parameters of these behaviors. And some of the things are, of course, a lot easier to manipulate than others. So it should be fairly easy for us, for example, to take any object and change things like location. You can move the objects around in there, and you can see immediately that it updates things like shadows. So everything is dynamic in the environment. It's kind of nice. You can see the shadow on the ground there as I move this. So it's a pretty powerful engine. And this you get all for free. This is cheaper than the Unreal editor that I just showed you. Because the Unreal editor I had to actually buy Unreal, the game, for $15. For this one you can just go and download this now. The Crytek is just giving away this editor for free with these assets that come with it. But of course you don't have all the assets of their games. You only have these assets. That's the difference there between this and the Unreal Tournament game that I bought. But you can get started with this, and you can really make your own environments. You can definitely use this environment to create a shooting game, or you could make even some kind of an adventure game out of it. There is an AI that you can script for all of the entities in here, and there's countless tools. So that's the CryEngine and the Unreal Engine. And then there was just a couple of more that I want to. Well, I should at least scroll. So Unity is an engine that it differs from both of these in terms of, okay, this is a general purpose engine. This is not built on top of a particular game, but you do get a free license to use this, and so it is quite accessible and nice to get started with it. And you can get many free assets in it from the asset store that Unity provides. So this is built on exactly the same principles as the other two, and in fact all of the game engines. You have a scene. The scene is represented by this box up here, the hierarchy here. That contains our entire scene that we are constructing. And then we drag game objects into that scene. We can drag them from our library that currently is under this project tab here. This is our library of potential game objects that we can browse, and we can bring them into our scene at our pleasure. Or we can also use menus to generate new objects, and we can create, for example, a plane object. So this is a 3D object that is just a flat surface, and I can move it up and down. And this is our first game object. So now our scene contains two game objects. It contains the main camera and the plane. And I can set this plane to be at any location here. And I can maybe bring in another object like a sphere. So here is another kind of a 3D object, and I can stick it in here somewhere. And I can maybe look at it from this perspective here. So, so now I have a couple of objects, and you can see that whenever I select any game object, this inspector here brings up all the properties of that selected game object. And the properties, they are divided into these different, sorry, what was the name of this again? Components, sorry. So the properties of each game object are encapsulated in different components that kind of implement a particular skill or a particular feature of that game object. And again, it is very important to understand that these components, they both have a data part, that is going to be some kind of a variable or something like that, some setting for the object, but also some behavioral description about how this game object is updated during the simulation. The game, again, being really just a dynamic simulation of objects interacting. So when I press the start button like that, there's not much going to happen right now. It's just going to be like that. But what is actually happening behind the scenes here is there's a simulation running, and every time the simulation does an update, it actually asks all the objects, do you have any behavior that you want to do now? And they respond, okay, I'm going to move this much, or I'm going to do this. So you can write these responses, essentially, to the simulation updates as scripts. And you attach scripts to any of these objects that will determine its behavior. And some of the scripts can come in from the browser. So, scripts are just other types of assets, in fact. And you can bring in some of these assets like directly as components and add them to a game object, and that will then receive that type of behavior. And I think we can even try, if we want to be adventurous here. We can add rigid body properties to this sphere. We should also add a light to the scene, because the scene was kind of boring to look at, in fact. And we can do let's do a directional light. It's going to be easier. So now we have a light here. Okay. There. And then when we start, you notice that this sphere that we had inserted, we can put it a little bit higher, that it now falls down and stops on that ground there. And this is a very important step that we took there. We actually added some behavior to a game object. And it's really a script, in a sense, that is being run somewhere. Someone has kindly provided us with a way to simulate physics for this object. And this physics component, we just dragged it in here as a rigid body component that is now associated with that object. So now when the simulation walks through the list of game objects, the simulation will walk through all of these. It will ask each of them, okay, how do you want to update yourself? And when it asks the sphere will know that it's affected by these physical properties, and there's gravity operating on it, and therefore it will update its location as a result of that. So now we already have a little bit of dynamics in our environment. So that's the general principles, really, behind how you work with scenes and game objects in Unity. And when you have collected a set of properties and behaviors into something that is getting quite complicated and maybe good looking or something like that, you can store it again into your library of game objects to use later and in other scenes, or maybe you want to make several copies of it, sort of as templates, or what the Unity called prefabs. And I think we can maybe even find some kind of interesting prefabs. Well, this is some kind of a prefab here. You can place them in here. I don't know if he does anything. He just sits there. Okay. But there was another. Here are some of the prefabs that exist in this particular library here. Well, one of the good prefabs to use is the first-person controller. So a first-person controller that I drag in here, we can take out the camera now. And the first-person controller is a complex game object that consists of a couple other game objects and some properties. And I can take it and we can put it on top of the plane here. Okay, here's our plane. Oh, it's there, okay. Place it there. Okay, so if I start now, then I am falling on top of the plane as if I was standing there. And it already responds to mouse and keyboard as basically the behavior of the first-person controller includes reading the mouse and keyboard to see what the user is doing and then updating this camera object that it contains. So now I'm kind of part of the scenery now as a first person, in a first-person perspective. So this is an example of a prefab that has been constructed for us, and there are all kinds of prefabs that we can drag into our scenes and get up and running really quickly. So this is Unit D. I will now quickly leave this, and the last thing I'm going to show you is that we have also possibilities of doing two-dimensional games pretty easily. This is an editor that is a free editor, but if you start using it, maybe you want to also get the license, which is not too expensive, in fact. And this is again this exact same principle as all the other editors. I mean, they are all the same in the sense that they always have a scene, and they always have game objects, and then you have behaviors you can associate with game objects. This one just happens to have a very nice, easy-to-use library of prefabricated 2D game behavior. So it's just, you can kind of drag and drop these behaviors into your environment very easily. If we start a new project here, just an empty screen, it reminds, it's a little bit, people might think it's a little bit like Flash, but it's not Flash, but it does operate in terms of layers that you can populate with different things. And so the lowest layer that you might want to populate is a tiled background, for example. And you want to put the tiled background there and get some kind of an image to place on the background. And that's our image. And we can place the image in a certain location. So now we have a tiled background. It's right there. And again, this is just a game object, and then you see all the properties associated with that game object here on the left. And if we want this to be a background, we don't want to be selecting it accidentally when we are working on top of it. So this we should just put as the bottom layer and put a lock on it. So this layer will not be editable from this point onwards, but I can add another layer on top that we are now editing. So we're just leaving the background there in the back. And now this the incredible power of kind of this editing tool is apparent when you take just a folder of images like that one, and you literally take an image and you drag and drop on top of it. And what it did was that it actually created a game object from that graphic that I just dropped in. And that game object is called a sprite, which is kind of the basic game object in there. Yeah.
There is one limitation to the free edition. You only get like 4 layers and like 100 events.
Okay. So yeah, so you have a small-sized project,
Yeah.
Unless you can go further with it. Yeah. But how much is the license though?
I think they have like a business and then there's the personal use.
Mm-hmm.
I think the personal use is about 70 euros.
Okay. So it's quite doable if you want to do a little bit bigger project to license this just for your own use. Of course, with many of these things, they kind of want you to get kind of the first blood, or they kind of want to get you hooked on something and then grow from there and start getting into bigger licensing schemes. I think for this environment, it is quite worth playing with. Simply because the speed of development to try out some ideas is quite fast. It's pretty good. one could always consider then also other environments when you have gotten down to like some of the basic mechanics. So this is a game object now. This character that I just put there, and he is in layer 1. He is on this layer here. Oh, where is it?
No, he's on there. There we go. You could click
Oh, I put it. I see.
the objects menu. If you click the player, you can see what layers.
Yeah. Oh, he's here.
Yeah, click that.
Yeah, that's
You can
him.
see there in the comments
Okay, so I wanted to get him into another layer.
on the properties to the side. You can see layers and layers here
Yeah,
above.
here. Okay, so I wanted to put him there. So now I'm in layer 1,
Yeah.
and that's him. Okay, great. So again, just like with we were seeing with the other environments, there's a behavior associated with any of these objects, and when you click on behavior, you can add a new script basically that is attached to this object. And so, yeah, we need the input object. Yes.
If you go into the behaviors, there's a 8-directional controller.
Yes, exactly. There should be an 8-directional controller in here, and that's the one. And so now it should be, but we also need to actually include the keyboard and mouse as input objects. But another thing we want to add is to have the camera scroll to this object. Whenever this object moves, we want the camera to follow it. And we can use the scroll to behavior for that. And then we don't want you to go off the edges of the environment. So that would be, what, this bound to layout. Okay, so now he's stuck inside, basically. Okay, good. And then we also want to add the keyboard and mouse as objects, as input objects. So we're just clicking through here to insert them all. And at this point in time, I think we're able to run it. And we have this guy here, and yes, so, what happened? It froze? No, I just had a bit of a hiccup. So now we have the image that I just dragged and dropped is now a dynamic game object inside the game engine, and it's being updated from my input, from the keyboard, and I can easily do things with the mouse as well. And the camera is following me. And one of the things that I found was very exciting about this particular environment is that this is exported as HTML5. So it runs in any browser, I mean any modern browser that is, that supports HTML5. So once you export this thing, you really have a truly portable game that you can work with. And just as a final thing here, I added some pre-built behaviors to this object, but you can really script some events that, yeah, it's this one here. So this is basically the script that you construct for your game. And the script is really based on events or conditions that have to be true to have those events happen. So you add an event here. So for example, a system event, that would be something that you can pick from a selection of system events. So like for example, even every tick, you could do something and you can perform an action every tick. And then you can select what object wants to do that action, and then you select, okay, I want the player to do something at every tick. And I don't know what we want to make the player do. I guess we can have him rotate or something. We can set the angle, rotate angle. Yeah, right here, this one, right? Set angle. Or rotate towards position or set angle.
If you press that angle,
Mm.
then you get out the angle. You should be able to put the mouse to.
Yeah, well, the angle is not really what we want. We want to have him face the direction, face the placement of the mouse, basically.
Yeah.
And so I think it might be just to turn towards is what we would want to get. So rotate maybe towards position. Or should we try that? Rotate towards position? Or set angle towards position. How about that? And then here we can fill in what position we want the angle to turn towards. And here we can just type out the names of objects like the mouse and properties like the mouse X and the mouse Y here. So it filled in for me. It just always showed me what objects are available and what properties are available. Let's see if this works if I run it. So now when I move my mouse, it's following my mouse cursor, that is. So I have just added a behavior that is updated in every single cycle of the simulation, and I've connected that sprite or that game object to the variable stored in a different object, that is the mouse object. The funny thing is about this environment is that you do all this programming through clicking, more or less, and then searching these boxes for available properties, for available behaviors. But it's quite powerful. I mean, the kinds of constructs that you have there are really powerful to create very dynamic interactions. And so it's very easy to have objects really modify other objects or have things happen in it. So I encourage you to try this, and you have tried it. You can maybe share your knowledge also of how this environment works. But this is called Construct 2, and there's some pretty nice tutorials. This is from a beginner tutorial. This here, you can continue to work on this to make sort of like a monster shooter game out of this. Or they have platform games also, that they have some very nice elements to construct from.
There's also on the forums, secure.com, they have like tutorials that like crackers, just put it in basic crackers make and solve stuff.
Okay, yeah. So you can retrieve other projects, use the projects. You can play all these projects online because they're all in the web browser. So this is a different kind of engine. But again, my final point is really that the principles are always the same. I mean, you're really, an engine is a dynamic simulator, and then you populate the simulator with game objects, and you set up these objects, and you set up a scene, and then you run the whole thing, and you see what happens. That's really just all that there is to it. And usually that's enough for you to work with. You do not always have to go all the way underneath and get the source code for the engine itself, the simulation engine itself. But it may be in some projects, but not all of them. So if you're interested in any of these aspects, you can always come and talk to me. And so my address is RU.is. And even if I have not tried all of the different engines, I've been trying to follow at least sort of what's going on in the engine business. And I can maybe point you in the right direction for the kinds of engines that you're looking for, the kinds of behavior you're looking for. So I'll try to be of any help if I can. But that's the end of the presentation. Thank you. I'd be happy to take a couple of questions here, but are there any questions that are burning questions at this point? If not, then we can just also talk offline afterwards. All right. And good luck with your work.